Welcome to the Deep Dive. Today, we're digging into something pretty fundamental. How do we actually make AI think better?
We're looking at a really interesting paper from DeepSeek AI. It's called DeepSeek-R1, incentivizing reasoning capability in LLMs via reinforcement learning.
Exactly. So we're going to unpack their specific approach,
Yeah.
which uses reinforcement learning to try and boost the reasoning skills of these big language models.
And this is super relevant for anyone tracking AI progress, right? It's not just about bigger models anymore.
No, it's about finding smarter ways to train them, smarter ways to get them to reason more like, well, more like us, perhaps.
So if you're listening, why should you care? Well, understanding these methods gives you a real window into what the next generation of AI might look like.
Yeah, systems that could be way more capable, maybe more helpful. We're going to try and cut through the jargon today.
Right, distill the key ideas for you. So our mission, if you will, is to explore how DeepSeek AI tackled this. We'll look at two main models they developed.
Okay.
First, there's DeepSeek-R1 This one's fascinating because they tried training it for reasoning using only reinforcement learning, just rewards, basically.
Right. No initial lessons.
Exactly. Then we'll look at DeepSeek-R1, which took that R10 foundation but added what they call a cold start, some initial curated data.
Okay. A bit of a head start.
Sort of. And then we'll touch on how they managed to take the reasoning skills from these big models and transfer them, distill them into smaller, more efficient ones.
And that's maybe the surprising part, isn't it? The idea that you could get a powerful reasoning AI mainly through this reward system, even without tons of pre-fed examples.
It really challenges the standard playbook for training these models. And they saw some really intriguing behaviors emerge during training, like an aha moment.
An aha moment. Okay, we definitely need to get into that.
We will. We've spent a good amount of time with this paper from DeepSeek AI to pull out the core insights.
All right, let's jump in. DeepSeek-R1, reasoning from scratch with just reinforcement learning. That feels, I don't know, fundamentally different.
It really is a departure. Usually you'd start with supervised fine-tuning, showing the model lots of examples of good reasoning.
Right.
Here, they wanted to see if it could learn more organically, just by trying things and getting feedback through rewards. DeepSeek-R1 was their first experiment with this pure RL approach.
So how did they actually guide it? What was the RL algorithm they used?
They used something called Group Relative Policy Optimization, or GRPO.
GRPO.
Yeah, and the clever bit about GRPO is its efficiency. Training these huge models costs a fortune, right?
Uh-huh.
So instead of needing a separate critic model to judge how well the main model is doing, which adds complexity and cost, GRPO estimates a performance baseline directly from a group or batch of the model's own outputs.
Okay, wait. So it's kind of judging itself against its own recent attempts?
That's a good way to put it, yeah. It looks at a set of answers it generated for the same prompt.
Right.
And the objective, the goal of the training, is to make the model more likely to produce the better answers within that set.
And how does it know which are better? That's the advantage function.
Exactly. The advantage is calculated by comparing the reward for one specific answer to the average reward of all the answers in that group. Better than average gets reinforced.
Makes sense. So what were the rewards? What counted as a good answer for R10?
They kept the reward system pretty clean, actually. Primarily rule-based. Two main things.
Okay.
First, accuracy. Simple enough. Did it get the final answer right? This works well for things like math or coding problems where you can easily check the solution.
Verifiable answers. Got it.
Second, they had format rewards. They wanted the model to show it's working, essentially, so they encouraged it to put its reasoning steps inside these special tags. Think and think.
Ah, the think tags. So building in transparency from the start.
Precisely. And crucially, for this R10 model, they specifically avoided using neural reward models.
Why is that? Aren't those usually quite powerful?
They can be, but they also introduce risks, like reward hacking, where the model finds clever ways to get the reward without actually improving the skill you care about.
Ah, gaming the system.
Yeah. And avoiding them also made the whole training setup simpler, less complex.
Okay. And what instruction did they give the model? How did it know to use the tags and provide an answer?
It was a very simple template, basically. Here's a problem. First, show your reasoning and think tags, then give the final answer and answer tags. That's it.
Really minimal.
Yeah, they wanted to impose as few constraints as possible to see how its reasoning would develop on its own.
Okay, the big question then. Did this pure RL approach actually work? Did it learn to reason?
The results were pretty impressive, honestly. They tracked its performance on the AME 2024 benchmark. That's a tough math competition.
Right.
During the RL training, DeepSeek-R1 went from a pass rate of just 15.6% all the way up to 71.0%.
Wow, that's a massive improvement just from rewards.
It really is. It shows this intrinsic learning potential.
How did that 71% stack up against other models at the time?
It put it right in the same league as OpenAI's O1 912 model on several tough reasoning benchmarks: AIM, Math 500, GPQA Diamond, Live Code Bench.
So competitive with the state-of-the-art purely through RL,
Yes. And get this, when they used majority voting.
where you generate multiple answers and pick the most common one.
Exactly. With that technique, DeepSeek-R1 actually beat OpenAI O1 912 on AIM, hitting 86.7%.
Incredible. So RL alone can get you there, potentially even further with the right techniques.
It strongly suggests it's a viable path, yeah.
You mentioned something about a self-evolution process earlier. What was happening there?
This was really interesting. They observed that over the course of training, the model spontaneously started generating longer reasoning chains, more tokens inside the think tags.
It decided it needed more thinking time.
Sort of, yeah. It wasn't told to do that, but it seemed to learn that complex problems required more steps, more detailed thought to get the right answer. It adapted its own process.
That's fascinating. It's like it's learning how to learn.
Exactly. And it wasn't just length. They saw sophisticated behaviors emerge too. Things like reflection, the model going back and reevaluating an earlier step in its reasoning.
Without being programmed to reflect.
Correct. Or exploring alternative ways to solve a problem, all emerging from the RL process itself.
Okay, that leads us to the aha moment you teased. What was
Yeah.
that about?
Right. So at one stage, an intermediate version of the model was working on, I think it was a complex equation. And in its output, within the reasoning trace, it literally generated the text. Wait, that's an aha moment I can flag here.
No way, it actually said that.
It did. And then it proceeded to correct its initial approach and find a better path to the solution.
That is slightly mind-bending. It recognized its own moment of insight.
It really underscores how RL might allow these models to develop problem-solving strategies autonomously in ways we might not anticipate.
Definitely. But it wasn't all perfect,
Yeah.
right? You mentioned some downsides to R10.
True. Despite the reasoning power, there were issues. Readability was one. Sometimes the think process was kind of messy or hard to follow.
Okay.
And the other was language mixing. It would sometimes unexpectedly switch between languages in its output, which is ideal.
Right, you want consistency.
Yeah,
So that naturally leads us to the next iteration, DeepSeek-R1, addressing those issues.
precisely. The goal with DeepSeek-R1 was twofold: fix the readability and language issues, and also see if giving it a bit of initial guidance could boost performance even further or faster. That's where the cold start comes in.
Okay, explain the cold start. What does that mean in practice?
Instead of starting the RL from a completely raw base model like R10, they first did some initial supervised fine-tuning.
So bringing back some of the traditional approach.
A little bit, yeah, but with a very specific, small, high-quality data set. This data set was filled with examples of really clear, well-structured, long chain-of-thought reasoning.
Like giving it some good examples to learn from before setting it loose with RL.
Exactly, setting a good pattern early on.
Where did they get this high-quality data?
They used a mix of methods. Few-shot prompting, giving a model a few examples and asking for more like them. Also directly prompting models for detailed answers that included self-reflection.
Okay.
They also manually refined some of the more readable outputs from R10 itself and involved human annotators to polish things up and ensure clarity.
So a concerted effort to create really good examples of reasoning. What were the main benefits of doing this cold start?
The biggest immediate win was readability. It dramatically improved how clear and understandable the model's reasoning process was.
Makes sense.
They even enforced a specific format for R1, special token reasoning process special token summary. So you always had a clear summary at the end. And they filtered out responses that weren't easy for humans to read.
Addressing that R10 problem head-on. Any performance benefit?
It seems so. By baking in some human priors about what good reasoning looks like, they found R1 generally started off stronger and potentially reached higher performance levels than R10 might have alone. It guided the subsequent RL more effectively.
Okay, so after the cold start tuning, they went back to reinforcement learning.
Yes, but this time the RL was specifically focused on reasoning-heavy tasks, coding, Math, science problems, logic puzzles, building on that initial foundation.
Did they tackle the language mixing problem?
They did. During this RL phase for R1, they introduced a specific language consistency reward.
Rewarding it for sticking to one language.
Essentially, yes. It measured the proportion of words in the target language within the reasoning chain. They had to balance this as optimizing purely for language consistency, sometimes slightly hurt raw reasoning performance, but it significantly improved usability.
A trade-off for better human preference.
Yeah.
Makes sense. What came after this reasoning-focused RL?
Then they moved into another data collection and fine-tuning phase, this time for supervised fine-tuning, or SFT.
Okay.
They generated data from the RL-trained model using rejection sampling, basically, generating multiple outputs and picking the best ones. And crucially, this time they weren't limited to just problems with checkable answers.
How did they judge the quality then?
They used another powerful model, DeepSeek-V3, as a judge for quality on these more open-ended reasoning tasks.
Interesting. Using AI to help train AI.
Exactly. They also mixed in non-reasoning data from their DeepSeek-V3 pipeline, things like general writing, Q&A, translations, self-awareness type stuff.
Broadening his skills beyond pure reasoning.
Right. This created a large, diverse data set, around 800,000 samples, which they used for the SFT stage.
Wow, quite a data set. Was that the end of the training?
Almost. There was one final RL stage. This one was about aligning the model more broadly with human preferences, helpfulness, and harmlessness, while still keeping that reasoning edge sharp.
So fine-tuning the overall behavior.
Yeah. They use the rule-based rewards for the reasoning data still, but for the general data, they use reward models. These focused on the helpfulness of the final summary and the harmlessness of the whole response.
A very layered, iterative process. Cold start, reasoning RL, broad SFT, then alignment RL.
Exactly. Quite comprehensive.
So the payoff, how did the final DeepSeek-R1 perform after all that?
Extremely well. On those tough reasoning benchmarks like A and Math 500, it was comparable to and sometimes better than OpenAI's O1-12-17 model.
So right at the cutting edge.
Definitely. It showed expert-level skill in Codeforce's programming competitions, and it also did great on knowledge benchmarks like MMLU and GPQ-A Diamond, actually outperforming their own previous best model, DeepSeek-V3.
Impressive. And not just reasoning.
No, it also showed strong abilities in creative writing and handling long documents. The combination of reasoning focus and broader training really paid off.
So that cold start combined with the iterative RL really pushed things forward.
It seems to be a very effective combination, yes. It fixed the R10 issues and boosted overall capability significantly.
Okay, this feels like a good point to talk about the next step. Distilling all this reasoning power into smaller models. Because these huge models aren't practical for everyone.
Absolutely. Critical step. Can we take the smarts from DeepSeek-R1 and transfer them to smaller open-source models like Quinn or Llama, making them more accessible?
How did they approach this distillation? Is it like compressing the big model?
The main technique they reported here was direct fine-tuning. They essentially used the big DeepSeek-R1 model as a teacher.
Oh.
They took that big 800K sample dataset, the one generated by R1 during its SFT phase.
The high-quality reasoning examples.
Right, and they used that data to fine-tune the smaller base models directly. So the smaller models learned by imitating the outputs of the highly capable R1.
So, learning from the teacher's examples. Did they do any RL on the small models?
Not in this specific study, interestingly. It was purely supervised fine-tuning using R1's generated data.
And did it work? Could the little models learn to reason like the big one?
The results were pretty striking. A 7 billion parameter Quinn model distilled from R1 actually outperformed much larger models like GPT-4o 0513 on reasoning tasks.
Wow, a 7B beating GPT-4o.
On specific reasoning benchmarks reported, yes. Their distilled 14B model beat Quinn's own 32B preview model, and their distilled 32B and 70B models were significantly better than OpenAI's O1 Mini across most benchmarks.
That's huge. It really shows the power of transferring that learned reasoning capability.
It really does. It suggests that maybe the knowledge of how to reason, once captured, can be transferred quite effectively, even if the smaller model couldn't discover it on its own.
Which implies that model size isn't the only factor for reasoning. The training data and method are critical.
Precisely. Which led them to compare distillation directly against trying RL on a smaller model.
Right. Could a smaller model learn reasoning via RL as effectively as inheriting it via distillation?
They tested this. They took a 32 billion parameter Quinn base model and trained it using large-scale RL, similar to R10.
Okay.
It did okay. It reached performance similar to Quinn's own 32B preview model, but it was significantly worse than the 32B model that was distilled from DeepSeek-R1.
Ah, so distillation won out.
In their experiments, yes. The conclusion was that, for empowering smaller models with strong reasoning, distillation from a highly capable larger model seems more effective and likely more economical than trying to get the smaller model to learn those complex patterns from scratch via RL alone.
That's a really valuable practical insight.
Yeah.
Use the big models to discover the reasoning, then distill it down.
Seems like a very promising strategy, yeah.
It's also useful, as you said, to know what didn't work so well. The paper mentioned a couple of unsuccessful attempts.
Right, learning from failures is key. They touched on two approaches that were less fruitful in this specific context. First was trying to use a process reward model, or PRM.
Rewarding intermediate steps.
Yeah, the idea is to reward the model for each correct step in its reasoning chain, not just the final answer.
Sounds good in theory. Why didn't it work well here?
They ran into a few problems. One, it's actually hard to define what constitutes a correct intermediate step in a general way for all kinds of reasoning. Two, automatically checking the correctness of those steps is tricky. And three, they still faced issues with reward hacking, and it added significant computational overhead.
So, more complex and didn't necessarily lead to better results than just rewarding the final answer.
In their experience, yes. The other approach they mentioned was Monte Carlo tree search, MCTS.
Like AlphaGo uses.
Exactly. The idea was to have the model explore the tree of possible reasoning steps more systematically.
Why didn't that pan out?
Primarily scale, it seems. The search space for generating text, token by token, is just enormous, much bigger than board game moves. They also found it hard to train an accurate value model to guide that search effectively in the language domain.
So techniques powerful elsewhere don't always map directly onto LLM reasoning challenges.
It's a good reminder, absolutely. Context matters.
Okay, so let's try and wrap our heads around the main takeaways from this DeepSeek-R1 research. What are the big achievements here?
I think there are three key things. First, R10 showing that pure large-scale RL can cultivate strong reasoning skills without needing supervised examples up front. That's a big proof of concept.
RRL as a path to reasoning.
Second, R1 demonstrating that combining a cold start with good data and then iterative RL can push performance to state-of-the-art levels, fixing issues like readability along the way.
The refined approach.
And third, the success of distillation showing that these advanced reasoning abilities aren't locked into giant models, but can be effectively transferred to smaller, more accessible ones.
Making powerful reasoning potentially more widespread. What are the broader implications then?
Well, it strongly suggests RL is a really viable, maybe even crucial tool for developing more advanced AI reasoning. And it highlights distillation as a key technique for democratizing those capabilities.
Where do they see this going next? What future work did the paper mention?
They listed a few interesting directions, improving the general abilities of R1 beyond just reasoning function calls, better conversation, handling structured data, that kind of thing.
Making it more of an all-rounder.
Yeah. Also, continuing to tackle that language mixing issue and investigating prompt sensitivity, how much the way you ask the question affects the reasoning quality. They seem to lean towards zero-shot being ideal, if possible.
Just ask the question. Don't give it examples.
Right. And finally, looking into more efficient RL methods specifically for complex software engineering tasks.
Seems like plenty more work to do. So as we finish up, what's the final thought you want to leave our listeners mulling over?
Maybe this. Consider the implications if AI continues to get better at developing reasoning skills more autonomously through methods like reinforcement learning. If it can effectively teach itself how to solve complex problems, what new possibilities does that open up? And perhaps what new challenges should we be thinking about as these capabilities evolve?
That's definitely something to chew on. The idea of AI reasoning evolving almost on its own, a fascinating, maybe slightly unsettling prospect.
It's certainly a space to watch closely.
Well, thank you for walking us through that complex research. That was a great deep dive into LLM reasoning.
My pleasure. It's fascinating stuff.
So for everyone listening, the big takeaway seems to be that reinforcement learning, especially when used cleverly with good data and techniques like distillation, looks like a really powerful way forward for creating smarter, more capable AI.
Absolutely. And if this sparked your interest and you want to go deeper, definitely look up the DeepSeek AI paper. There's a lot more detail in there and plenty of related research exploring RL and LLMs.
And as always, we'd love to hear from you. Let us know what you thought, or if there are other topics you want us to tackle in a future deep dive.
Your feedback helps shape what we explore next.
Until then, keep learning, keep questioning.